All right, welcome to part 2. You are watching this if you want to go over the answers from fish inches before you try the assessment practice. So let's kind of review. We worked on fish inches and we took a look at two different graphs. If the fish inches is 3, so over here in this one, if fish inches is 3, then the gallons is going to be 2. If fish inches is 2, I'm sorry, if gallons is 2, then fish inches is 3. All right, so these are kind of, these 2 points right here are showing you that relationship of 3 to 2. 3 fish inches per 2 gallons of water, okay? I think we went over most of these questions, but I'm gonna go over them again quickly. The 0.00 means that there are 0 fish inches, 0 gallons of water. You've changed your mind, you're not getting any fish. So what does that 0.69 mean on the fish inches per gallon graph? So that's fish inches per gallon, this one. And that means that it's 6 gallons of water for 9 inches of fish. What does it mean on the other graph, gallons per fish inch? That means that it's 9 inches of fish for 6 gallons of water. It's saying the same thing, it's just the way it's oriented, how we switch the X and Y axes labels. One and 1.5 on fish inches per gallon represents 1.5 fish inches for 1 gallon of water. So remember, 1.5 is 3 halves. So remember, we see that 3 to 2 ratio. So 1.5 fish inches for 1 gallon of water, and that's a unit rate because it's per 1 gallon of water. And the 0.123 on the gallons per fish inch graph means that it's 2/3 gallons of water for 1 fish inch. That is also a unit rate. And notice, instead of it being 3/2, it's 2/3. See, it's math magic. So what is the unit rate for each graph? Explain how you determined it. We kind of just talked about it. We talked about the fact that this right here is a unit rate. And this is a unit rate, depending on what you're talking about. Are we starting with gallons of water or are we starting with inches of fish? So either you're dealing with 1.5 fish inches per gallon of water or 2/3 of a gallon of water for each fish inch. So 2 different unit rates you could have. The graphs look similar. They're just, this one kind of goes up a little steeper. This isn't as steep, but they're giving you the same information. It just depends. Am I starting with gallons or am I starting with fish inches? So how many inches of fish can fit into 10 gallons of water? How many? If you said 15, you are correct. 15 inches of fish. And how many gallons are needed for 7.5 inches of fish? Look at this relationship here. So if you said 5 gallons, you are correct. 7.5 is half of 15. 5 is half of 10. Math magic. Now, keep in mind that these say to estimate. All right, we're not going to have an exact answer. They're going to be approximations. So how many gallons would be needed for 16 inches of fish? About 11 gallons. So if you said somewhere near 11, 10 something, or a little over 11, that's fine. 11 gallons is what we're looking for. And then how many inches of fish for 16 gallons? We're saying about 24 fish inches. Okay, and so let's wrap this up. So the constant of proportionality from a graph. So this graph shows the relationship between time and distance that Ella runs. Define the variables and write an equation to represent the relationship between Ella's distance and time. So let's look at the values here. So I picked X to represent the time because it's on the X axis. You might have said T is time in minutes. That would have been logical. Y is our distance in kilometers. Excuse me, it's because it's on the y-axis. You might have chosen D for distance. And the equation that would be written is if I take X and I multiply it by 1/6, that will give me Y. So if I have 12 times 1/6, that equals 2. This is a good one here. It's 24 over 4. So if X is 24, Y will be 4. So 1/6 times 24 equals 4. Don't get frustrated. This is some practice. We're going to be doing more with this, okay? And that's also why I want to see how you do on the little quiz, because you may realize more of this than you think. Because this gets like wordy, you know, so do I. So use your equation to answer each question. How far could she run in 15 minutes? She could go 2.5 kilometers or kilometers. How far does it take, or how long does it take her to run 7.5 kilometers? Oops, takes about 45 minutes, or it takes 45 minutes, assuming she's running at a steady pace. How far does she run in 1 hour? Well, if 15 minutes is 2.5, there are 4 15s. So we must be talking about 10 kilometers. So now what I want you guys to recognize is that we're trying to move away from just using tables and proportions to start using equations to help us solve problems. Mathematicians are always looking for that more efficient way. So tables are fun, they're great, they help us make connections, but we also have to be able to interpret graphs and use equations. So we discovered that the constant of proportionality in the original equation is 1/6. What do we constantly multiply X by to get Y? All right. So if I'm trying to figure out the distance, if I, instead of saying per minute, what if I said it was per hour? So I'm changing it up, and I don't want to write the equation per minute. I want to write it per hour. So what would I have to multiply each hour by to get, or I'm sorry, what would I have to multiply each time by to get the distance? So I would have to multiply 10 by 10. So I would take the amount of time she travels by 10 to get the distance that she travels. Because remember that 1/6 is connected to 60. 1/6 of 60 is 10. So 60 minutes in an hour. Hopefully I didn't confuse you with how I just explained that. If I did and you understood it this way, then don't listen to what I just said. Just keep going with your thinking. So how's the equation the same as and different from the previous equation? So I kind of just talked about that. Both equations show that Ella's distance varies directly with time. There's definitely a direct variation. It's definitely a proportional relationship. In this first one, D equals 1/6 T. That shows me how many kilometers she runs per minute. In this one, when I change the 1/6 to a 10, that shows me how many kilometers she runs in an hour. How much she runs in an hour. Okay, so make sure that you have completed this. I've just given you all the answers, so I still need you to go in and work through it because this is your notes. And if you choose to do it in your workbook, that's fine. This is directly from the workbook. This was on these last two slides were from pages 132, 133, M1, 132, and 133. So tomorrow, my plan is to show you it's more of like a 6th grade review lesson to get you ready to think about percents and finding like percents of numbers, figuring out tax, commissions, gratuities. So tune in tomorrow. Please make sure you try that assessment. I want to see what you know, and let me know if you have any questions. Just send me some emails. And also don't forget to check if you have any missing work. We're running out of time. All right. So let me know if you need help, and I'll see you soon.